Welcome to PsyDactic. I am Dr. O'Leary, and today is Monday, March 10th, 2025. I am a child and adolescent psychiatry fellow in the National Capital Region, and this is a podcast about psychiatry and neuroscience. I make this podcast myself to help me learn more deeply my field and new developments. My staff consists of me, myself, and I, and while we do often argue with each other, we don't have outside opinions or editorial staff or fact checkers to keep us in line. So everything you hear here should be considered my opinion and my opinion alone. Today I want to introduce you to one of my side hustles. I have a sister podcast to PsyDactic called PsyDactic Child and Adolescent Psychiatry Board Study Edition. And in this one, I go through the American Board of Psychiatry and Neurology's criteria for the board exam for child and adolescent psychiatrists. I'm trying to do a topic on as many of the included subjects as I can as a way to help me study for the boards. I thought I would introduce this to you so that anyone interested could pop on over to PsyDactic CAPS edition and check it out. I'm going to start with 2 episodes about behavioralism, just to give you a little taste. I won't waste any more of your time. Here is PsyDactic CAPS edition. Welcome to PsyDactic CAPS Board Study Edition. I am your host, Dr. O'Leary, a child and adolescent psychiatry fellow in the National Capital Region. This is a podcast I designed to help myself and other CAPS fellows study for their boards. But anyone interested in human development or mental health will likely also get something out of this. If you want to know how this podcast is produced, please go back and see episode 1. I say that because I'm using an AI assistant to help create the content, and episode 1 explains how I do this. But even though I'm using AI, all the content in this podcast should be considered to be my opinion and no one else's. But if you find errors in the content or you have suggestions for improvement, I would love it if you went to PsyDactic.com and filled out a form there to let me know. There's also possibly a link in whatever app you used to listen to this podcast that says send a text to me, and you might be able to contact me that way. I have so far in this series discussed some of the early psychosexual, psychosocial, and cognitive approaches to child development. But I would be remiss if I did not also mention a group of theorists who attempt to study humanity by basically ignoring the fact that they have thoughts and emotions. The behavioralists tried to simplify the study of humans by massively simplifying their assumptions about humans and other animals. But in the end, people are really just interested in themselves. In fact, behavioralists are primarily criticized for vastly oversimplifying everything. For instance, they assumed that behaviors were basically just reactions to the environment without any real deeper meaning. These responses are learned based on environmental inputs. Whatever else is happening on the inside of the creature is either irrelevant or extraneous. All we can really see are behaviors, so we should just study and talk about behaviors. As oversimplified a view as this is, it did unlock a revolution in applying the scientific method to human and animal behavior, which wasn't very common at the time. So we can thank them for helping us understand the roles of conditioning, including how we make a benign stimulus in the environment become a powerful motivating or punishing factor by pairing it with something else over and over and over again. Even more ubiquitous in psychiatry and psychology are the roles of reinforcement and punishment in learning and behavior. But before I talk about most of the people you probably have already heard of, like Pavlov and Skinner, let me mention one figure who helped to start it all. His unassuming name was John Watson. John Watson conducted some experiments in his day, and in 1907, he conducted what's been called the Kerplunk experiment, and I'll explain why it's called Kerplunk in a moment. And it's considered one of the pivotal studies in the development of behavioralist theories. And it focuses on the understanding of how rats learned to navigate mazes, which you'll hear about a lot if you read the literature about behaviors. So here's just a quick breakdown of the experiment. The first phase of the experiment was a training phase. So rats were trained to run down a maze, and there was a straight alleyway in the maze. At the end of that alleyway, off to the side, was a food reward. So over time, the rats became really, really good at navigating the maze, and also when they got to that straightaway, they would just like run down it, get to the food, and eat it all up. And they did this over and over and over again to learn it well. So once the rats were well trained, the manipulation phase started. Watson and Carr shortened the alleyway to the food pretty dramatically without any obvious signals that the alleyway ended. So the maze is basically just a single color. The food was still present there, but now it was a lot closer to the starting point of that alleyway instead of way down in the distance like it used to be. So after they manipulated the placement of the food, they observed rats going through the maze again. And of course, they're good at the maze, and when they find that alleyway, they ran at full speed and they crashed headfirst into the wall, making this kerplunk sound. And that gave the experiment its name. But more than just giving it its name, it gave it its meaning. So the experiment demonstrated that rats have developed a strong habit of running the original length of that alleyway. And the habit was so ingrained that they were unable to adapt in real time to a change in the maze, even if it meant missing out on the food reward. So maybe you've heard of muscle memory? Well, from what I read, I think this is where that term kind of got its start. So Watson and his colleague Carr argued that rats had something called a kinesthetic sense that we also have. And we are primarily relying on our kinesthetic sense to navigate the world, including the maze. This is an awareness of our body's movements. So once we've learned a specific sequence of movements, the sudden change in the maze disrupted that learning pattern. So the rats couldn't adapt in real time. In order to adapt, you have to learn, and they had learned the wrong thing. So when you change the environment, they failed. So this experiment challenged basically what was a traditional kind of stimulus response view of learning, which suggested that animals are going to respond directly to the external stimuli in their environment at the time those stimuli are presented. Instead, the Kerplunk experiment showed that learned behaviors become kind of automated. They're resistant to change, even when the environment changes. Now, I'm going to take an aside here and say that this experiment, I think, more than being in line with a behavioralist view of the world, actually gives evidence to a more modern idea called active inference, which was first laid out by a neuroscientist, Carl Friston, and it kind of posits that an agent in the world acts upon the world so as to create the reality that they predict, rather than merely as a simple response to external stimuli. But pretend that I didn't just say that right now, because a discussion of active inference is not really at home with this quick review of behavioralism. So let me get back to behavioralism. So the Kerplunk experiment provided evidence for Watson's idea that behavior is largely a product of learned associations and habits, muscle memory, a kinesthetic sense. Then along comes Ivan Pavlov with very similar ideas, and he's a Russian physiologist, and he conducted research on what became known as classical conditioning in the late 19th and early 20th centuries. His experiments primarily involved dogs, and he wasn't really trying to do classical conditioning experiments at first. He really accidentally stumbled upon what he later called classical conditioning. So he was a physiologist, and he was studying a dog's digestive system, basically, in particular, how they salivate in the presence of food. And he observed that dogs naturally salivate when they sense the food itself. This is an innate reflex. But he noticed that dogs would salivate as well when a bell was rung, because a bell was rung before the dogs got food, so they could ring the bell without presenting the food, and the dogs would salivate anyway. So let me go into a little bit more detail. At the beginning of the experiment, Pavlov was just initially measuring the amount of saliva produced by dogs when they were presented with food. So this is like the baseline for kind of a natural, unconditioned salivation response. Then Pavlov introduced a neutral stimulus, the sound of a bell, which initially is not going to elicit any salivation response. So they measured that it did not elicit a salivation response by itself. But then they're paired together. And the neutral stimulus is presented with the food over and over and over again. And after several of these pairings, Pavlov observed that the dogs began to salivate in response to the bell alone, even when there was no food present. So the bell had become what is called a conditioned response. The food was an unconditioned stimulus, the bell was a conditioned stimulus, and the food became a conditioned response. So let me review some of the key kind of findings and principles of classical conditioning. First, there is the conditioning itself. There's a neutral stimulus, and if you pair it repeatedly with a conditioned stimulus, you can elicit a conditioned response with the conditioned stimulus in the absence of the unconditioned stimulus. But this requires some sort of response that would have happened anyway in the beginning, so there's something innate in the response to begin with. The second is an acquisition phase. So you can learn this if you do it over and over again. And then there's an extinction phase. So if you take that conditioned stimulus, the bell, and you just ring it all the time without the food present, then over time, salivation's not going to happen as frequently and it will gradually go away. But then if you wait a while after you've caused an extinction of the response and you ring the bell again, the response could reappear again. So that would be called spontaneous recovery. There's also a kind of generalization that can happen too. So Pavlov observed that dogs would salivate in response to a stimulus similar to the bell or to the conditioned stimulus. So if you took a different bell with a slightly different tone, but it was similar enough, then it could result in the response. So it wasn't a super specific stimulus needed. So this is known as generalization. However, if you took similar items and you rang one without any response for a while and the other with the unconditioned stimulus, then a process of discrimination could arise where the dog could figure out that the small difference between the bells was an important difference, and they would not salivate to the bell that was not paired with the stimulus. So that's Pavlov. Dogs and bells, but a whole lot more than that. I'm going to summarize for you in a minute classical conditioning, but before I do that, I want to talk about Little Albert. So Little Albert was an experiment that was also conducted by John Watson and with Rosalie Rayner, and it was at Johns Hopkins University in 1920, maybe even 1919. It's one of the most famous and controversial studies in the history of behavioral psychology. So it aimed to demonstrate that emotional responses like fear could be learned through classical conditioning. So let me explain. The subject of the experiment was a 9-month-old infant named Little Albert. He was assessed to be an emotionally stable infant. He showed no abnormal fears of the environment. He was demonstrated various stimuli like a white rat, a rabbit, a dog, a monkey, various masks. And he was not afraid of any of these things. Then they started to pair the white rat with a loud noise. So they'd strike steel bars with a hammer. So it's kind of a really clanging bang noise. And of course, he's an infant, so he would be startled by this, and it frightened him. And they did this over and over again. They paired the rat with the loud noise. So after several pairings, they reported that Albert began to exhibit some fear. So he'd start crying or crawling away in response to the rat itself, even without the noise present. So the rat had become a conditioned stimulus, and it elicited a fear response in a human. At the time, this was considered to be pretty revolutionary, but looking back at it, it was also very unethical. In fact, it was unethical in more ways than just scaring babies. So, in the first place, there was no informed consent. Albert's mother, who was a wet nurse at the hospital, was not fully informed of the nature of the experiment and provided with consents. They just asked, "Can we use your baby? We're not going to hurt him," kind of thing. And it may have caused psychological harm, right? I mean, there's lots of things that go clang in the world, and if you condition a baby toward the clanging, that's not good. Plus, you're inducing unnecessary fear into a child, which itself has ethical concerns. And then there's really no follow up uh, assessments, any long term, like, determination of psychological impact on the baby. But anyway, it was done. And despite its ethical issues, the little Albert experiment had a significant impact on the development of behavioralism. So it demonstrated classical conditioning in humans. It provided evidence that classical conditioning could be used to explain the acquisition of emotional responses in humans, not just these other kinds of physiological responses. And I'm not exactly sure at the time whether they thought of emotional responses as physiological responses. Nowadays, I think most people think emotions are very physiological, but I'm not sure at the time if they knew that. And it suggested that phobias could develop through learned associations. So if someone was afraid of something, maybe it was because it was associated with something else in their past that was bad. But I've also read that even though it's considered a landmark study in psychology, its actual results were not very impressive and may have been greatly exaggerated when they were reporting them. Like maybe Albert didn't have quite the reactions that they said. It was a single kiddo, and they were reporting things the way that they wanted them to have been. So maybe they exaggerated it a little bit, or a lot of it. But in the end, it inspired a plethora of other researchers who attempted to explain this stimulus response in humans. So before I wrap up this episode on behavioralism, I want to review classical conditioning. So this type of conditioning was proposed by Ivan Pavlov kind of by mistake. And it is a process in which an organism comes to associate an initially neutral stimulus with a otherwise meaningful one. And here are its key ideas. There is an unconditioned stimulus. So this is a stimulus that just naturally elicits a response without any prior learning. For example, the food for the dog. Then there's the unconditioned response, which is the natural unlearned response to the unconditioned stimulus. For example, salivation in response to the food. So you have the unconditioned stimulus and the unconditioned response, and they happen no matter what. But then you have the conditioned stimulus. So this is a neutral stimulus. You have to prove that it does not actually cause the response before you can call it a conditioned stimulus. And you associate it with the unconditioned stimulus through repeated pairings. And then this results in a conditioned response. The conditioned response is the same as the unconditioned response, but now it happens with the conditioned stimulus instead of the unconditioned stimulus. But Dr. O'Leary, why do bells and dogs even matter? Well, that's a great question. Thank you for asking. So this could explain lots of things, and I'm just going to give some examples here and hope that your brain can make up a bunch for yourself. So the first could be something like a food aversion. So an unconditioned stimulus might be food poisoning after a specific food. The unconditioned response would be nausea and vomiting. The conditioned stimulus could be the smell or sight of that specific food, and the conditioned response could be feeling nausea again, or disgust when encountering that food, or even vomiting when you encounter that food again. In this example, actually, there's not repeated, or I hope there's not repeated like pairings of the food with vomiting because of it has some sort of chemical in it. But the intensity of the one time could even result in further nausea and vomiting. Another example could be like the placebo effect. For example, classical conditioning might predict that a person who takes a medication that gives a certain result physiologically, like for example, a beta blocker, which slows their heart rate, might, after many times of taking it, work even if you're taking a placebo of that same medication. That would be like a sugar pill that you thought was the drug. Or you leave the house with a memory that you took the medication, but you actually forgot. You could still have an effect of the medication, and that would be a classical conditioning type effect. Today I discussed behavioralism and classical conditioning. But next time I'm going to discuss operant conditioning. And I think operant conditioning has had more of an effect on the way people do things, simply because it's, I think, a lot easier to understand than classical conditioning, because it talks about things like rewards and punishments. So for parents, this is great, or for employers, or video game makers. Before I end, I would also like to remind you that you can go to PsyDactic.com, fill out a form there, just tell me what you think about any of these episodes. I also have another podcast called PsyDactic, just PsyDactic, where I explore a lot broader set of topics that are not just associated with the boards that a child and adolescent psychiatry fellow is going to take. So check that out if you want to. In the meantime, thanks for listening. I'm Dr. O'Leary, and this has been an episode of PsyDactic, Child and Adolescent Psychiatry Edition.